Mishra. Today I will take your class on architectural acoustics. In architectural acoustics, we have discussed about the importance of architectural acoustics in architecture. Now I will talk about absorbers. So in absorbers, we have main focus on room acoustics and role of absorbers, types of absorbers, their working principle, target frequency range, porous and frictional absorbers. Room acoustics may surfaces and shape of room, purpose of room, reverberation time, and role of absorber. The process by which a material, structure, or object takes in sound energy when sound waves are encountered as opposed to reflecting the energy is termed as absorption. Means absorption is a process by which structure, object takes in sound energy when sound waves are encountered. They are as opposed to reflecting energy. Reflecting the energy is termed as absorption. Means it is absorbing the material. The object is not reflecting but the opposite of reflection, that is absorption. Part is absorbed and a part is transmitted through the absorbing body. If a sound energy encounters on any object, there are some parts which get absorbed and some parts are transmitted through the absorbing body. There are two kinds of sounds. First is the direct sound. We use direct sound to gauge direction and general tonal quality. We use to direct sound. Direct sound means a sound which directly goes to the listener, and there is a reflected or indirect sound that bounces off the walls, floor and the ceilings. जो वॉल, फ्लोर और सीलिंग से रिफ्लेक्ट होकर आता है, बाउंस ऑफ होकर आता है, उसे रिफ्लेक्टेड साउंड या इनडायरेक्ट साउंड कहते हैं. वी यूज दिस साउंड टू गेज द डिस्टेंस. we use this sound. We generally gauge the distance. What is the difference between direct sound and reflected sound? That must be less than 15 meter. 15 meter. If it is going beyond this limit, it means it is creating noise. We use this sound to gauge the distance we are from sound source. The size of the environment we are in. Theoretically, the noise reduction coefficient alpha represents the average absorption between 250 Hz to 2000 Hz. Bass and treble refers to lower and high frequency respectively. Means if there is lower frequency, it is from 250 to 1000 Hz. It is known as bass, and treble is the higher frequency range. Means after 1000 Hz to 2000 Hz, we categorize it as treble. Controlling them through absorption is also important. So controlling both of them, the bass and the treble, is very important. Knowing the source frequency and also the target frequency to be absorbed successfully is important to get quality sound. Knowing the source frequency and the target frequency to be absorbed means which quality of sound is to be produced by the source, and which type of quality of sound is to be absorbed, how much is to be absorbed. That is very important in an architectural acoustic. If we want to get a quality sound, we need to know that what is the source frequency and what is the target frequency which is to be absorbed. Sound energy gets transformed into other form energy after hitting the surface. If it is getting absorbed, it means it is getting converted into another form. It is getting converted into another form of energy. Heat energy due to frictional losses, vibrational losses, these are the some type of other transformed energy. Then we come to know that what are the different type of absorbers. Then first is the porous absorber of frictional absorber, second is the panel absorber or vibrating absorber, third is the resonant absorber or cavity absorber. As we know that porous absorber or frictional absorber are those absorbers when a surface is being designed in such a manner where some portion is taken into hollow and small holes are created due to friction losses. These type of absorber absorb the heat and absorb the sound energy. Panel type of absorber or vibrating absorber. If we see any restaurant or any gathering places, we found these type of absorbers. In this type of absorber, the sound energy is being vibrated. It get reflected from the absorber, that is known as vibrating or panel absorber. Third one is the resonant absorber or cavity absorber. In this type of absorber, the main focus is given on the cavity. The bigger than the porous absorber, holes are created and these are used to absorb the sound energy. All hard smooth surfaces are reflectors and their absorption coefficient is very low. Hard smooth surfaces are reflectors and their absorption coefficient low. If there is absorption coefficient of 0.2 and it is the thresholding value of absorber, it means that if absorption coefficient is less than 0.02, it means it is a reflector. It is a reflector. The acoustical impedance is measure of the resistance to motion to a given point. It is one of the most important properties of material which leads to sound attenuation. The acoustical impedance is measure of resistance to motion at a given point. Resistance to a motion at a given point. How much resistance it is giving at time of motion. That is known as acoustical impedance. It is one of the most important properties of any material which leads to sound attenuation. The specific sound impedance which is most frequently encountered in acoustic is defined as the ratio of sound pressure to the associated particle velocity at a point. That is, it means Z is equal to P upon U, where Z is acoustical impedance in Newton second per meter cube, P is sound pressure in pascals, U is acoustical particle velocity in meter per second. Then we comes to know about as we have discussed about the porous absorber, low frequency, low flow velocity increases, local flow velocity increases due to porous absorber. Direct changes leads to high frequency losses. Friction with particles lead to heat and low frequency losses. For this porous type of absorber, we have example of fiberglass, mineral fiber products, fiber board, pressed wood shaving, cotton felt, open shell neoprene foam carpet. Thicker the absorber, higher is the absorption. At 500 Hz, maximum vibration is absorbed. At 2000 Hz, the beyond similar absorption disseminating coefficient. Panel type of absorber or porous tiles are used to absorb the sound energy. In this type of absorber, 1/4 inch staggered holes at. These are the qualities, these are the types of porous absorber. 1/4 inch staggered hole at 3/8 inch open cut, 40% open. 1/4 inch staggered holes at 500 OC, 58% open. 17/64 inch staggered holes at 516 OC, 65% open. Perforated at least 80 to 20% fall of the facing should be open to perform the absorber as porous absorber. Perforated metal screen are also employed and can be effective as long as there is sufficient open area and the hole sizes are not so large that the spaces between the holes become reflecting surfaces, or so small that they become clogged. Airflow through absorber creating a standing wave within the cavity. The absorber doesn't move. For most architectural application, a 1-inch thick absorber fiberglass panel applied over a hard surface is the minimum necessity to control the reverberation for speech and intelligibility. High frequency flutter echo can be reduced using thinner materials such as 3 upon 16 inch 5 wall fabric, 1 by 4 inch 6 carpet. If low frequency energy in the 125 Hz octave band of concern, then at least 2 inch 15 panels are necessary. At even lower frequency 63 Hz and below, types of the absorber are required. At even higher frequencies Y and beyond 2000 Hz, porous absorbers are not effective. Carpet on floor or one of the example. Now panel absorber. Panel absorber are non-porous lightweight sheets, solid or perforated. They may be freely suspended. Means this type of suspension may be there, and they may be fixed having a air cavity behind them. They may be fixed as a air cavity behind it and filled with absorptive material such as fiberglass or filled with uh, fiberglass. A freely suspended non-porous panel can absorb sound simply due to its mass reactance, that is induced mass. Application mostly seen in large open spaces, usually hung from ceiling. They can be hung from ceiling in form of sheet and will vibrate to dissipate sound energy. As we have discussed earlier that this type of sound energy is lost through vibration. Acoustical waffles are ideal for areas where sound deflects off hard surfaces. Acoustical waffles look good and remove the echo effect in large rooms. Baffles and banners. In large volume spaces, baffles and banners are most economic way to get a good sound absorption. Sound intelligibility is important. Sound intensity level reduced. Reverberation time reduced. Application are mainly in arena where we have a large ceiling, a large volume is there. We generally prefer vibrating type of absorbers. Arenas, gymnasium, theaters, multi-purpose halls, auditoriums, we found these types of absorbers. When a non-porous absorber is placed in front of the solid surface with no contact between the panel and the surface, the panel can move back and forth, but it is resisted by air spring force. So this is the type of absorber. Now resonators. Spherical type of air spring oscillator is an enclosed volume having a small leg and opening at one end. It is type of vessel where we have a neck and we have the body. A true hand resonator must have a volume, a neck and an opening. The dimension are to be small component with a wavelength of sound to be absorbed. In reality, we have necklace resonators where there are perforations in a plate against an enclosed volume. In a perforated plate, the perforation form small tubes in air which have a mass and thus a mass reactance to the sound wave takes place. Next type is sound box unit. In sound box units, we have cavity. So in this type of absorbers, we create some type of box where we provide some type of cavities where sound energy goes in and it doesn't come back. It get absorbed through those cavities. The size of box is taken from 41 centimeter to 20 centimeter. The depth is taken from 10 to 15 or 20 centimeter. Adequate wedges. These are ideally suitable for entrapment of low frequency sound. Most suitable lie lightweight open cell form having pyramidal form is appropriate. Slit set resonator. In this